Hello everyone. Today we are going to discuss the difference between types of NoSQL databases. Firstly, we have to understand the main difference between SQL and NoSQL. SQL is a type of database management system which involves tables and it has a very clear way of storing data. Like for a table, if you have names, then only the names will be stored in that column. So that is how SQL actually works. But for NoSQL, everything is associated with different types of data and it has many connections, and that connection leads to a good storage system. What is the main advantages or the features of NoSQL databases? So the NoSQL databases has flexibility and it is very scalable. One of the biggest point to note here is the scalability of NoSQL databases. How the scalability comes? The scalability comes from many different types of databases, and you have different types of NoSQL databases which can be arranged for artificial intelligence, like for supervised learning. Unsupervised learning, you can do many different types of things, and it is actually one of the biggest it has one of the biggest application of big data analytics, which leads to the analysis of different types of data, and it will be actually used for data analytics. And the other feature is the high performance for specific use cases, like for specific, as I told you, in artificial intelligence you can have supervised learning, and different types of techniques which can be used for high performances. And then the third point is about the distributed architecture which it actually possesses. Like as I told you, there is different types of architectures, like we have document oriented, and then we have different like key value store or column based, or different types of um, like architectures, which actually helps in tolerance, and it has good availability. Fault tolerance in the sense, like if there is any kind of failure in the system, or if there is any kind of data failure or corruption of data, all of these faults can be actually tolerated well enough by the NoSQL databases. Coming to the next point, we have something about the horizontal scalability. Horizontal scalability means we can have good scalability. We can have good scalability um, using like by adding many computers. As soon as we add more computers to the system, what happens is that the scalability is increased. And then we have something called as polyglot persistence, in the sense there are many types of architectures, as I told you. Like you have document oriented, we have column store, we have key value, and then you have graph databases. All of these can be managed by the NoSQL excellently. On your right side, we can see few logos of different types of NoSQL databases like Apache Cassandra, MongoDB, and many more. Coming to the difference between the different types of NoSQL databases. So for this, we have divided the different types of databases into four columns. The first one is key value database, document oriented database, column oriented, and then graph database. So these all the differences can be actually noted by the different features or the different parameters, that is the data model, schema, querying, use cases, examples, and then we have scalability, consistency, performance, data modeling, and deployment. Coming to the first feature, the data model, how the data is actually stored in these NoSQL databases. In the key value databases, these data are stored as key value pairs. So how does that happen? Very simple. Okay, you have a key, and for that you have a value. Okay, so whatever data you want to search in that database, you can fetch it by just clicking on the key or just typing the key, like 001 for a name Aditya. So you can just add 001, and then you can have the data which is corresponding to that key value. So then for document oriented database, you have different types of formats, like JSON or XML format, which is actually mainly used in your Mongo database, which is actually one of the biggest NoSQL database. And for column oriented database, you have organized data in tables by column rather than rows. Like you don't have rows for one data, but you have columns for the data storage. And in graph database, what we have is it represents and stores data as nodes. Okay, very simple. You have one node, you have another node, you have the third node, you have the fourth node. So the data is connected like a mesh or any way which is best possible um, for the user or for the application. And then how is the schema? It is actually schemaless and it allows more flexibility. And it is for document oriented database, you have a schemaless data storage, which is allowed by the flexible schema. And then in the column oriented database, you have fixed schema. And then for graph database, you have a schemaless store, and it is actually a dynamic data structure. So what happens is, like, real time data can be stored, like, as soon as the data is collected, it can directly reflect into your graph database. And for querying, you have I mean, as I told you, 001 for Aditya, so you have an optimized efficient key based retrieval. You just add the key and you get the data for it. And for document oriented database, you have rich querying capabilities on document attributes, like for the JSON or the XML format. But for the column oriented database, you have the different column based. Okay, so this is column based queries which can give faster analytics. For all the columns, you can get a faster analytics. And then you have a graph database. For querying graph database, if you think it in a logical way, then you have different types of traversals which can happen. Okay, so, like, you have a DFS BFS which can be used for graph traversals. And then where is the use cases for all of these? So key value database is mainly used for caching or storage. And then we have document oriented database for real time analytics, and then column oriented database for warehousing. And then you have graph database for social media, like, Instagram, Facebook, or Twitter. They use graph database, so it is connected. And then using AI, you can get the most recommended feed. Okay, then you have the example of key value is DynamoDB, Redis, React, and then for document oriented, we have MongoDB, as I told you. And then we have column oriented database, which actually, one of the biggest application of column oriented database is Apache Cassandra. And then for graph database, we have ArangoDB, Amazon Neptune, which is actually powered by Amazon. And then you have Node4j. Coming to the next slide, we have different few more parameters to discuss. I mean, this slide is actually my favorite, or one of the most important topics which has to be understood if you are using a NoSQL database or NoSQL database system. And then for that, we have scalability, consistency, performance, data modeling, and deployment. This is all about the application. Okay, so the scalability for the key value database is very, very, very scalable. Okay, so, like, it can handle large amount of data. Okay, we have map reduce also. When we are doing map reduce, what happens is the input is taken, it is first mapped, and then the reduced part is being used. Okay, so, like, that data is reduced. So then we have document oriented database. It is where it is scalable, and it is usually supports horizontal scaling. So what do you mean by horizontal scaling? You are adding more and more computers, so that you're powering up the system. So that is called horizontal scalability. And then you have column oriented database. It is actually designed for your horizontal scalability, and it is capable of handling massive data sets, which is actually very useful. Graph database, it is very scalable and it is very efficient. But one of the most important thing we have to understand in graph database is all about traversals. Okay, and then in consistency, what we can talk about is, like, what is the end result, like how is it going? Is it going good every time, or is it shaky, or is it not going good? So, but in key value databases, it is having eventual consistency with support for strong consistency when required. We are very much knowledgeable with the base theorem, like, basic availability, and then you have soft state, and eventually consistent path. So this is where all of it comes in. And for document oriented database, we have various levels of consistency from eventual to strong. So it is little bit little shaky in terms of consistency, and in column oriented it offers eventual consistency. And in graph database we can have ACID transaction. ACID, A stands for atomicity, C stands for consistency, I stands for isolation, and D stands for durability. So this is how it all works. And in performance we have high performance for key value, and then a document oriented also has good performance in terms of querying and any other things. And then we have column oriented, which is actually optimized for fast analytics. And then we have graph database, which provides efficient traversals algorithm for structures and relationship. And then we have something for the deployment. In deployment we can see that it can be deployed, the key value databases can be deployed on premises in the cloud, which I actually told you, like the map reduce. And then document oriented is also the same thing, but in the column oriented it can be deployed on premises or in the cloud, which can support distributed deployments like in the distributed system. And in graph database we can see that we have hybrid deployments, and then you have clustering, sharding, and then scalability can be achieved from this. So this is all about the difference between the different types of NoSQL systems. I hope you all understood, and then thank you for watching this video.